Listing of the loopback software, and it is written in C. And I'm going to walk you through the program. Uh, C programs are written in usually structured in a strange way. You would think that you'd start at the beginning, but every C program is entered uh, by calling a function called main. And so the place to the place to start is with main. Uh, the stuff, this other stuff, these are functions that get called in certain to do certain things, and I'll talk about those later. Uh, the stuff up front here is got to do with setting the environment for the program and defining certain parameters and whatnot. But we'll get to that. At least I'll touch on that lightly. Okay, so we start out by defining two integers. One called RET, which is uh, basically used to retrieve status from functions. Um, a function is a unit of code that you can call by name. And for example, main is itself a function, uh, and each function returns a value. Uh, and typically, uh, one value is for failure and another value is for success. So when you call a function, it will doesn't have to, but the convention is to return a value, at least one value, telling you whether it was successful or not. So um, the second integer here is used as uh, a file descriptor, or in our case, this is going to identify the device uh, driver, or the device for the SPI interface. So stick with me here. This will become clear later. Uh, this is a call to a parse options is a call to a function that retrieves command line arguments uh, from the call to main. So, for instance, if you were calling this program directly and you had um, uh, and you wanted to modify the function of it by adding parameters, parse options here would recover the parameters. Uh, More about that later. Okay, so here we have FD equals open device 0RD WR. And what this is saying here is this is calling the driver for SPI, and it's asking for a file descriptor. And a file descriptor, all that is that's something that allows you to talk to the device. So here's an attempt to open the file descriptor, and the next line says that if the file descriptor is resolves to a negative value, it means that the device it failed to open the device. In this case, it failed to open the the uh, the SPI device, which would be in this case would be the Raspberry Pi's master. Okay, so the we see that the function called here is called PA abort, which we'll get to, but basically all it's going to do is it's going to display a value to the user, in this case can't open device, and then the program's going to quit. If you get past that point, you come down to this code, and this is a call to a function that sets up the in your case it sets the device up, which in your case is the spy master, and it sends some parameters to it, and then it gets a value back. This is a status telling you whether it was successful or not. And if it returns a -1, it means that basically it failed, and it exits the program. And if it doesn't fail, then let's see here. What's this one going to do? Oh, yeah, this first one here is trying to set the spy driver up for write mode, and the second one is trying to set it up for read mode. And you can tell because of these constants here, they have these resolve to numbers, and the numbers are the status bits or the parameters that it takes to set the spy interface to a particular mode. So it first tries to set it up to write, and if that's successful, it sets it up to read. Or is that read? Let's just a second here. Oh, excuse me. No, I've interpreted that wrong. What it's trying to do is it's trying to write information to the spy device, which here is called FD. We opened FD here, and now we're using FD in this code. And let's see here. What is mode? Let's go back and find mode. Okay, well, mode is a value that we recover from the command that calls this program, and I'll go over that later. But suffice it to say, we're writing information to the spy interface here, and the value that we're sending is the mode. And if that's successful, we're reading back that mode, and just as a check to see whether it was actually set. Then we come down here, and we're setting up how many bits per word there are, and then reading it back. And then we're setting up the speed, and then we're reading it back. And if all of that goes well, it'll print out information. It'll tell you what the mode is, it'll tell you what the bits per word is, and it will tell you what the speed is. And and then this is what really does the work. There's a function called transfer, and we pass transfer the descriptor to the spy device, and that's where the data gets transferred. So let's go take a look at transfer, see what goes on there. Transfer is declared up here, right here it is. And what transfer says is that it's this is C syntax for creating an array. And so all that's happening is these bytes are being put into an array. And the array is called TX, probably for transmit. Down here is another array which is being used, which will be this will be the thing that you might call the transmit buffer, and down here would be the receive buffer. And so down here, all we're doing is we're telling the program what size the receive buffer is. And then here, let's see here. Let me figure this one out. Struct is basically a user-defined data type which puts all of the which puts certain numbers of parameters under names that makes them identifiable. So this struct, which is being called is being called TR for transmit, consists of it says here unsigned long TX. That's just a way of saying this thing right here. It's telling it that TX buff is filled with this information. And this one is simply telling you that there's another thing called RX buff, and it basically, in this case, you would want it to be at least as big as the transmit buffer. This tells you the length of the buffers, and this delay is apparently I don't know how delay is used, but it's a parameter for the SPI, probably how long it waits between bits. And this next thing, speed, is probably the speed parameter that was defined earlier, and then the number of bits per word. So this basically encapsulates everything you need to know to transmit your data and receive the data back from the SPI driver. Down here, let's see here, what's this? Okay. Down here, what this says is it wants you to talk to the SPI driver. It has a message. Don't know what the one means yet, but then it tells it that the thing it's to handle is this structure here. So this is a way of passing all of the parameters in a single variable to the SPI master. And then basically we get a status back, and if it's negative, it means that we couldn't send the message. And we exit. If it's not negative, then let's see, what's this? This is the code that creates the output that sends back to the user the data. And you've seen this. This is the output that comes up on your screen after the program runs. Okay, so getting down to maybe something that you can use immediately for your purposes. I know that this can be kind of confusing, but actually, when you break it down, it's not all that bad. But I'll show you something here. Remember how I said that you could write the program in such a way that it kept transmitting? Well, what this program does is it comes through here, it transmits once, and then it closes the device and it quits. When you return from main, it always means that the program is quitting. So, suppose you wanted this to transmit continuously. Well, you might do something like this. Let's see. I want to get correct syntax here. Okay. So here's what we'll do. It doesn't matter where this bracket is. The style. This what this says here is while one means true. So what while means is as long as this value is true, which it will always be because we've made it one, execute this line. So what that will do is that will just transfer over and over and over and over again. Now, one thing I don't know is whether or not uh, uh, this will overrun the SPI interface. It probably will. And overrunning means that you write new data before the old data is finished being transmitted. So uh, let's see here if we can. We might want to put something in here to delay, and the easiest way. Let me see how the best way to do this is. Uh, well, I have to look this up, but we could possibly put a delay in here. This, by the way, doesn't put a delay in there. It just tells you, it's just a note to remember where to put it. I'll have to figure out how to do that. There's probably a function we can call that delays things. But anyway, uh, at least in a crude sense, this will make the thing transmit continuously. Although because of the fact that there's nothing to slow this down, now let me see. Maybe there's a way to let's see what whether transfer. Let's see what transfer does here. Okay, I think this will work because of the fact that the transfer uh, routine does not return until the data has been sent and received. So you probably don't need the delay here. This will probably work, and it's really simple and it's worth a try. And if it doesn't work, let me know, and I'll try to come up with something that will work. Uh, so uh, just to satisfy your curiosity, I'll go through some of these other things here. Um, these includes are uh, definitions. In C, you have a thing called a header file, and they're a little confusing at first, but basically, uh, in a program, you can't use a variable until it's been defined. And what a header does is it defines certain variables, and these are based on this. Uh, these are some standard things that you include in a program, and you can see down here we're getting into something that's rather peculiar to this particular program, which is it's pulling in a header for spy device.h. Um, and that is uh, not every Linux operating system or system will have a spy interface on it, but these are the definitions for the variables used in the spy interface. Don't get too concerned about that. Uh, this is basically just defining the sizes of the transmit and receive buffers. Let's see, array size of A. Where does A come from? I don't know where they got A from. Uh, this is actually a something called a macro. Don't worry too much about that. Uh, PA abort. Okay, this is the routine that gets called when status fails, and all it does is it basically this star S here is the message, such as can't open spy interface. P error is a function that prints that out, and abort quits the program. You you actually might want to short circuit this because uh, when you start looping and transmitting continuously, it might start kicking errors out, and this would make you quit the program. So something you could do here that would prevent that from happening is come here and just comment the abort line out. And what'll happen is it'll print it'll tell you what's wrong, but then the program won't quit. It'll just keep running. Um, so let's see. This is a this is a little bit hard to explain, but it this well, I won't even try to explain it, but basically it has to do with being able to talk to the spy interface, and this thing device. It's basically what this is telling you is where to find the actual spy device. Uh, Mode is just defined uh, so that you can put information in it, and I'll show you that when we get down through here. Uh, Here's where you define bits. If you wanted to try 16 bits, you could just come in here and just change this number from 8 to 16. Speed, um, um, any speed you want. Although at some point it won't be able to keep up. You could slow it down a great deal, which might give you a little bit easier time seeing what's going on with the scope. But this is basically the clock speed, and I don't know where delay is used, but we'll encounter that somewhere down here. Okay, so we've already been through transfer and what that does. Now, if you wanted to send something different, what you could do is you could put different values in here. Now, what this means is uh, these are this 0x syntax means that the number is a what's the word they use? Hexadecimal. And hexadecimal FF is a byte which has all ones in it. And what they've chosen to do here is to fill this buffer with values. These are the exact same values that get printed out when the program for the program output. And if you run this program and it works properly, you'll see this on your screen without the 0x. It'll just be FF, FF, FF. You could set these bits any way you want to. And in fact, if you wanted to use this as the basis for reading your ADC, all you would have to do is well, there's a way that you could address this array and change a particular bit in here on the fly, but that don't worry too much about that right now. You can write anything in here you want as long as it begins with 0x and it has only 2 characters. The characters are go between 0 and FF, and what it means is if you look at this in binary, 0 is all, like right here, 00 is all bits low. 01 would be the least significant bit high and all the other zeros low, all the other bits low. And basically each one of these are actually numbers even though they look like letters, because hexadecimal has 16 values instead of 10. So when they get past actually past 9, the next character is A. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So you could look at these as numbers. And you only each one of these characters represents 4 bits. So an F is all 4 bits high, and another F is all 4 bits high. That defines a byte with everything high. But not to get into that too much. So down here, you also have to, when you receive something, you have to have some place to put it. So what they do is they define a receive buffer that is the size of the transmit buffer, and not quite sure what this does. I think this sets the whole thing to 0. And then of course this is where you set up the variable that gets transferred to the driver, and this is where the message is actually sent, and then down here they receive the message. So this sends it out, this receives it back. Okay, so this has something to do. This is basically this would be a prompt. This doesn't really do much of anything, but this is a prompt. If you try to start this program and you don't send it something it understands, it will print this out to tell you uh, what the options are, what you should have entered, and you can, by reading this, you can tell what the program does. If you put minus D there, it it allows you to specify which device should be used, and the default is to use the SPY device. The if you minus S, what this means is in Linux they often have what they call command line switches, and there's two forms. Minus D is accepted, and minus minus device is accepted. So it doesn't mean that you have to write minus D space minus minus device. You can either have minus D followed by your parameter or minus minus device followed by your parameter, whichever you please. And here you can change the speed. This allows you to change the delay, and I'm not sure how the delay is used, but it probably affects. Well, let's see if we can find that somewhere. I'll look for that later. So these are all of the things, all of the ways you can modify the execution of the program through the command line. And down here, Parse Options, this is where, after you start the program calls this to figure out whether or not you have supplied any options, and it figures out what they are. So let's see here. So it's looking for the options. This is where, let's see. Okay, so this is actually where the business starts down here. C has the value of the option in it, and if C is if the option is D, which corresponds to this D up here, then what it does is it takes the value from the command line and puts it into the device variable. Same for speed, same for all the rest of these. That's because I'm curious about delay. Let me see where that guy comes in. What is delay called? Delay is little d, lowercase d, right here. Okay. Okay, so delay is one of the parameters in the values that we transfer to the SPY the SPY driver, and don't know what that means, but that you could play around with that a little bit. It probably is the amount of time between bytes. And so if the thing is overwriting on the command line, just give it a value for D and see what happens. So anyway, that's the basic idea, a little bit long-winded. Not really a complete explanation, but it should give you something to work with and a little bit of an idea about where things happen. Now, if you do make a change here, of course you have to recompile the program. And let me see here. Where is that stuff? Let me see if I can find this. This thing where it says SPI latency, that I haven't read this, but it would be a good thing to read, which, remember me talking about overwriting? This will probably give you some information about that. Okay, so down here, this wget blah 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 pulls in. All it does is it reads this file to your computer, which is the loopback program. These lines right here compile the program. And let's see here. And this is what runs the program. And you can see by this that it uses the -D, which is the device, and it tells it to use device SPIDEV 0.0. If you remember, in the source code, it had SPIDEV 0.1. My guess is that the 0.0 and the 0.1 refer to the different slave selects. So if you had two slaves, one you would write to one by writing to device SPI-dev 0.0, and the other one by writing to device SPI-dev 0.1. But that's just a guess. These right here are things that are output by the program, and let me just show you where those are. Okay, this is what writes that stuff to the console. And then this is the values coming back. Remember the 0FF. This is basically the transmit buffer being read back into the receive buffer and then displayed to you. So that occurs where right here. Okay. This is where that's written out. The value that comes into the receive buffer gets written to the screen here. Any place you see print F and put S also is another output thing that outputs to the console. So and what you'll see is that the thing that's in the receive buffer, if the receiver's working right, will be exactly this, except without the 0x. It just prints the letters out. So you can see that there. So anyway, that's the basic idea. Hopefully that gets you started. If there's anything confusing, just call me or email me, and I'll try to figure it out. Okie dokie.